Morning, everyone. So despite the good quality of the other talks, I'm happy to see so many faces here. I haven't spoken publicly for a year, so forgive me if I seem nervous as I am. Okay. I want to talk today about writing stream processes in Kotlin. And before we start, just a little agenda, because I have no agenda slide, is we will dive a bit into Kafka. The depth of how deep we go into Kafka depends a bit on you, because the first question is basically who uses Kafka? Geez, okay. Okay, we need to balance a bit the introductory part, because we have some people here who have never seen Kafka, maybe never seen Kafka before or heard of it and have yet no use case for it. Therefore, I will do a bit of introductory, so to pick these people up. Well, let's do a quick look over the shoulder where Kafka really comes from. And was developed at LinkedIn. So open source since 2011. Still, it got its 1.0 rather recently, about a year ago. And does anybody know why it's named Kafka? Anybody read the Quora thread? Why Jay Krebs named it that way? No, he said, okay, it's a tool made for writing, and he loves the works of Kafka, so it's that simple. So there's no kind of secret sauce behind it. Okay, let's go quickly through Kafka in a nutshell. We have something that's called a broker. A broker is basically a running instance of Kafka. You can run multiple of them on a server, but you do not want to do that. So you want one per physical machine or one per virtual machine. We have a few roles here. So we have a producer, which is basically things that write into Kafka. We have a consumer, things that read from Kafka. We have a cluster. A cluster is one or more machines. Within a cluster, we have topics. That's basically the smallest unit you can address on a semantical level. Then we have one layer deeper, what we call partition. That is basically Kafka's thing to scale. The more partitions you have, the more threading you can have, or the more threads you can throw at it. The more hard drives you can leverage later on if you distribute the partitions evenly over hard drives. We use, for example, just a JBot setup, so just a bunch of disks. So we do not have a RAID 10 or something underneath, but we use multiple directories. So Kafka is able to address multiple directories for storage. And so we just give it 10, 15, whatever directories for writing. That gives us a good performance. But we come later on to the context where we at Trivago use Kafka and what for, etc. Okay, so what's special about it? It's persistent. So many people who uses the usual MQ fellows, like RabbitMQ, ActiveMQ, something in that regard. Okay. Mostly, I say mostly because there are products that have support persistence as well, at least persistent until picked up. But Kafka itself is really persistent, so you can make it, or you can use it as a database, but we'll come to that in a moment. Time and log compaction, so forget things after time. That is kindly the behavior that you know from, for example, Kinesis, if you do AWS. So they are forced to do your stuff within 7 days, else it's gone. And Kafka is at least able to do the same, although you have more than 7 days if your hard drives allow that. And you have a log compaction. We come also to that in a moment, which is compaction by key. Kafka itself is key value store. And we have guaranteed order per partition. That's basically the killer feature if together with log compaction. So messages have a byte key and a byte value. That's very much important. It's also where the performance of Kafka comes from, because it does not interpret the data it receives. It just spits it on disk and streams it out again. That's also why spinning Rust, also classic hard drives are a good idea to use with Kafka. You can use SSDs, you get also performance kick for it, but Kafka does mostly sequential reads, sequential writes, which is ideal for the old spinning Rust, and it's cheap. So you can do 10K SAS drives, and you're really happy with that performance. And we have metadata like timestamps. The timestamp has been added in past 0.8. So that's a rather new feature. You can scroll in the time. I personally, I think we at trivago never used this feature ever, but obviously there are people who are interested in it and also paying for that. So we have the anatomy of a topic. That's a bit basics to understand why later on log compaction is so interesting. The topic itself consists of partitions, and the numbers you see within these are the offsets. They just count. It's just an increment that counts. It's a long, so you can count for a long time. And yeah, every message basically gets an offset. So, and the pointer always points to the next free offset. So if you read through the topics manually on the low-level API, don't forget you basically get always one off. That's something happens frequently to me. And you see the old to new down here, which means basically when you perceive this as time, you just append here. The allocation to these single partitions is based on what you spit in there. So the one thing is event streams. Event streams normally have either a null key, so no real key, which then would trigger a round-robin assignment to the partitions, or you have a semantically meaningful key, and that would then trigger a murmur 3-based hashing, so that the same key always is lands in the same into the same partition. Together with the order, this gives us a ordered stream of update events or change events, for example, for a given key. I have a slide to explain that. So, but event streams have a null key or a bare serialized value, a bare or serialized value. You can also spit in longs there if you want to, or whatever makes you happy. Compaction by time, and for example, click streams. The typical user behavior on a page, or payment transactions if you want to. Logs. We use it heavily for logs, and things like IoT events, for example. Also pretty good. Then we come to log compaction, which is basically the other side, where you look at Kafka more from a database perspective. That's a bit, for many people, harder to grasp. It took a lot of time for me too. So we have before compaction, and you have the offsets that we have seen beforehand, and you have the keys here, and you have the values here. You recognize that some of the keys reoccur, especially key 1, for example, with different kinds of values, or key 2 should also be, yeah. And when this compaction runs, so when the background compaction thread starts and does the work, it basically removes all older versions of a given key. So it keeps the latest state of a given key. That also, where the value also can be null. So there is a special semantic attached to log compaction, where a key and a value means basically a state representation, and a key and a null value means basically a delete. This is wonderful because then you can also represent database changes in it. So change data capturing. Did anybody hear of Debezium? Well, yeah, you're out. So Debezium is basically exactly doing this. It behaves as a replication slave to a MySQL, to a Postgres, and serialize these events from the bin log or from the write-ahead log into Kafka, so that you basically can replicate over Kafka. Stream processors. Imagine it as Kotlin sequences, but based on incoming data from a server. So it's basically an infinite and potentially infinite stream of messages. These are stateful. That means if you do transformations to it, it has local state. Local means not necessarily hard drive, although that's the preferred way because it's the fastest. They heavily use RocksDB for that as a key value store, because Kafka's key value, RocksDB's key value, both speak only byte-byte, so that's pretty good. That works pretty good. And But you can also switch to other backends, like just in memory if you want to, or you can also use S3 or something. But you normally do not want network travel in between, because then you lose basically the benefit of being very fast. Parallel, as I said, the partitions are kind of the method to scale in Kafka. Means the more partitions you have, the more parallel compute power you can throw into a stream processor. If you have like 10 partitions, for example, you can either run a stream processor with 10 threads, or you can run 10 of them. That is of your choice. So if you have like more the micro scaling approach, or if you do, I don't know, Kubernetes or something, then you scale in a single container multiple times. Or if you have kind of the big bare metal machines, then you just throw something with 10 threads at it, and you get a decent performance boost. The key is that you should, you're not forced to, but you should output a Kafka topic as, or one or more Kafka topics as the result of your computation, because your computation is potentially expensive, in terms of resources, which means you want to have the results somewhere. You can write directly into a database or into your cache or something, but if you lose basically the state, like you use ephemeral hard drives, or your Docker container gets rescheduled and loses basically the whole disk, that's a pity situation if you need to reprocess like a few gigabytes of data, and this will take a few seconds to a few minutes to a few hours. That's not the time you want to wait, or your MTTR, until you want to have your system up again. Therefore, my recommendation is just spit it out into one or more Kafka topics, then you have it quickly available, even though the data might be stale. Now, that's okay-ish. If you opt into Kafka, you need to acknowledge that you do an eventual consistency, and not like something like reading out of a database. Yeah. So, what now? I wanted to bring an example for you why I think Kotlin is superior for writing stream processors. And I thought, like, do I bring a case directly from trivago? And I said, okay, there's too much business knowledge involved, and really to grasp why we write it that way is a bit of cumbersome. Therefore, I brought you something from my home automation. So I do home automation a lot. I use Homey, which is a German product that does multiple protocols. It has no official API yet, but they unintentionally made a boo-boo and leaked one of their AP blueprints on the GitHub repository, which I surprisingly found over Google. So now I have an AP blueprint file, and guess what? It's a WebSocket. Wonderful. So it spits out my home events over WebSockets, which is perfect because I can do something with it. So let's get started. WebSocket issues text messages, JSON. Wonderful. So any attribute that changes of any device, any connection, any temperature change, everything just gets like spit out over the WebSocket. And Kafka comes with a lot of framework support. So you have the bare consumers, so the usual stuff that you know maybe from Spring or so, where the Spring libraries are built on. And they also have something that's called Kafka Connect, which is basically the streamlining framework for ingesting data or getting data out of Kafka. Means you have kind of like 2 or 3 interfaces to implement or to extend, and you suddenly have something that can transport data into Kafka and out of Kafka very easily. There's not much like ceremony that you need to do. You can run in a distributed mode, and so look into it if you need to put something in or want to get something out. And now, I used to, with a friend of mine, we used to build a Kafka Connect source that reads from the WebSocket and transforms the data into Kafka. So that is not the official logo of Connect. Please don't Google it for me. It's just from PowerPoint. There is no official logo for it, but I needed to represent it somehow. So from the Homey cubes into over Kafka Connect into Kafka. So let's look at it. So first of all, nah. Damn it. Give me a sec. This way, that way, okay. Readable? Yeah, I guess so. Okay. So we use JSON for simplicity. So it means we have data classes to represent basically what the home automation system gives us. It's really serialized into JSON, into byte arrays, UTF-8 encoded, and just ran through. There's no magic involved here. That is just that you know that if you encounter the attribute class over the course, that's just a data class with everything in there. So a node basically is any kind of actor or sensor in the system. Now it means any temperature sensor or like a relay switch or whatever. So then let's look at, so we need to serialize and deserialize data. So that's also a concept that you find everywhere in Kafka. You have serializers and deserializers. So serializer means from a structured concept like a map of string object or string any, or a business object of any kind to byte array, and from byte array back to something. At trivago, we use protobuf heavily. So for us, protobuf is the kind of business representation later on in the source code. So there is basically the thing is like you have a serializer, you have a deserializer. In this particular case, I made them very, very specific, so directly to the class. Normally, you want to have this more generic. Maybe you can do some kind of reified type thing and pass it on to Klaxon. That would make the code a bit more dynamic. In this case, it's where So, let's start with the Java representation of it. That's a commented one. So writing stream processes is pretty easy because you have a minimum amount of ceremony. So the only thing you need to know is basically what's your unique ID and which service to talk to. That's the only thing you need to start things up. And so, oh no, please don't tell me that the laser pointer is, yeah, okay, I need to jump. Okay, we have line numbers, so. From line 22 on, we have the builder pattern. It's, you can see it's Java 10 with the var syntax, so don't get confused by that. So we have the streams builder, we have the serializer, the SERD, and we have a stream of attribute events that is consumed with a long serializer for the key and a attribute SERD for the value. The long one is just for you need to fill something in there. So there is no null serializer. I don't have keys, yeah? But they're all null capable. So I take a simple one. So then we filter basically and just say, okay, for every event that comes in there, thank you. So for every event that comes in there, we see if the attribute type of the event we get is a motion alarm. If not, don't pass it down the line. So it just gets swallowed at that point. With the remaining, we do a GroupBy. One thing you need to remember is with Kafka Streams, you can do basically everything that SQL algebra gives you. So you basically can do joins, you can do filtering, you can do GroupBy, close to everything that SQL algebra gives you. With a bit of limited flexibility means you don't have kind of like join on a subfield. Yeah? You join on keys. But joining on subfields, you need to rekey first, and then so you do the manual steps that the database would do underneath for you. But you have enough of the algebra available. So then we do a GroupBy by the node ID, which means we get for a repeated triggering of a motion sensor, we would then get a node ID, which node ID it is, plus the amount of events later on. And we window that by 2 seconds. So if somebody just rushes through the room, we're not interested in turning the lights on. Yeah? But if somebody really moves into the room or starts waving hands or something, then we want to trigger that, because then we assume that the person stays longer in the room. So we count that and filter, and if the amount is basically larger than 3, so waving hands basically, then we map, so we let it through, and then we remap, because this window by gives us a bit of different object at hand, or a different combination of key and value at hand. We map that back so that we have the node ID back at hand. No? Map the values and then put it back into a stream, because we have a windowed stream here. We want to get back into a normal stream. So we basically condense it back to a single message instead of multiple messages. And spit that out into a notified topic. That basically is consumed by another sink. So we are back into the Kafka Connect world, and the sink then spits out via WebSocket back to the home automation system, which then triggers the lights. And that is, so who of you guesses this is happening below a second? Above a second? Below 500 milliseconds? Okay, we're getting close. It's 80 milliseconds on a wired and a private. So it's prosumer equipment. So I have a Ubiquiti network at home, and so it's not like Fritzbox or something, but it's 80 to 100 milliseconds until the message is processed, but you have still the travel time from the home automation over Z-Wave to the appropriate actor. So that takes another 200 milliseconds roughly, so you have it under half a second. Yeah. So that's the ugly version of it. So let's see what the Kotlin copy-paste transliterator from JetBrains can do out of it as a first step. So that's literally just copy-pasted the Java code into a Kotlin file from the IDE. We see a few improvements already. So you see here, because we have data classes and data classes have components, we use the component destruction syntax here as a bit nicer. We can use underscores for the whole crap we don't want to use. So we can get less visually distracted from things that we do not use anyway. The syntax is a bit more readable here. We can use, instead of object equals, we can use the equals sign, because Kotlin will do the right thing. That is also a bit prettier, but still not really pretty. And we can also wrap that into the run, because that is kind of less allocation for variables and less visual clutter. But still, I'm not satisfied with that, because you can do more. And more in this case means that we can boil it down to this. It's the same main function and does the same thing. What we do here is basically we go into the details in a second, but we have a function that returns a function. So we have a pre-configured stream processor context. This context could be reusable, so you could do that multiple times after each other, or in multiple threads, or whatever, with the same configuration settings. And with a stream of motion events, when a node ID occurs more than 3 times per 2 seconds, we notify lights in the node group. And that reads really as what it does. You can also start to play around that with your business code. If you have operations that reoccur and reoccur and reoccur, like validation is a wonderful example for that you can like encapsulate validation in that. The code will be on GitHub. The slides will be on SlideShare or Speaker Deck or something, so you get access to that. So let's quickly look into how is that composed. We haven't changed any of the logic, so you find all the lines in there that we have had previously, so you don't need to look for details there. You have the configured stream context, which is a function that gets config and has also an auto-start optional parameter, and we assume that true is the thing you want, basically. And it returns a type alias, which is called stream_proc_builder. The type alias is up here. It's a function that, or it's an extension function block that returns a Kafka stream. Kafka Streams is a library. That's from the library, so I think I must say that. So what you have here is you instantiate Kafka Streams, have the stream builder, apply the block to it, call build, and the config.properties to the Kafka stream, and if it's auto start, you start it. That's basically the ceremony beforehand and the ceremony afterwards, after the inner block of business logic. So that's basically abstracted away. And now we go to the other extension functions, which is also not that much. We have the StreamMotion Events, where we have also the attribute events as the default parameter here. And you see, and that's the wonderful thing I personally think about these extension functions, you can also do them on generics, and they also just hit you if the generics are really there, which makes it really beneficial in the situations where you have concrete classes in the generics that are your business objects. So, for example, we have a hotel, for example, and you can execute certain validation logics only if the value is a hotel. And else the developer doesn't get distracted by, like, oh, why should I validate the point of interest here? That makes no sense. So you can also, again, reduce the clutter, reduce the error margin while developing software. Same down here, you have map values to streams. So you find all these basically, which are the lines from beforehand. No? So there's no new line added, there's nothing replaced here. And I think you could still improve that. So that is just like 15 minutes or 20 minutes of thinking and then just writing it down. Is there any questions with Boolean answers to this? Okay. Then let's go on. Well, that works. No, better. Okay, so now why Kotlin? So the Java code indeed didn't look that bad. No? So it was not right like the thing you would expect when you write like JAXB or something, yeah? or Apache Access. Well, let's look at the engineering view. So it's less verbose, it's better to read. No? That goes also in the direction which Andre proposed in the keynote. There are very much similarities in the reasons. Why? So extension functions, I think that's the most awesome thing to build a really approachable code, because you can in a context-sensitive way, you can guide a developer by designing the API properly, or by enhancing the API properly. One can argue that the DSL might be a similar tool for that, but especially when you work with libraries that you do not have under control, extension functions really kicks ass. I tried once to build a DSL around the Kafka stream surface, but you need to wrap everything into delegates and need to return that. That's really cumbersome. And no, you don't want to maintain that. So the smallest API change, you can revamp your whole library. That's nothing you want to go for, or at least I know. So extension functions can also be called from Java folks. So you can share these things. It's not that you build something that only the Kotlin folks can use, but you have static functions where the first parameter is the receiver. You can use that. Java folks are accommodated to worse things than these. Yeah, one can write libraries and business abstractions. That's what I basically already said. Let's switch to a team leads view, because for some time I do people management now, and from a team lead's perspective, for me different things count, because onboarding people is way easier for me. So it reduces the time and also the complexity of onboarding. Especially, trivago comes from a PHP-Java split world. So PHP in the front end, Java in the back end, and we at the moment move certain areas of the business code to Kotlin. And it's really, easy is a bold claim, but it's way easier to onboard PHP people to Kotlin code than to Java code. I don't know if that's kind of a mental barrier or it's really the code itself, but that worked out pretty good for us. The education material is rich and really based on current teaching standards. So I'm looking at you, OCP. Yeah, so that is, if you read the study books, that's very cumbersome to read. People need a lot of time to digest that. It goes very deep and good information, but not for people who are interested in building production software now. Yeah, that's something that really is an educational path. People love the language, and immutability helps a lot to prevent the usual errors that you have when you approach Java the first time, like concurrent modification exceptions and iterating array lists. So the standard things people fall over the first time. And you can write properly, really proper code without knowing the language very much in depth. You can add new aspects to your code base over time, and still write working software. So quickly, to wrap that up, Kotlin at trivago, so more than 80% of our Kafka-related source code. There's one team that insists on writing Java, but the other teams who work with Kotlin, who work with Kafka, do Kotlin. So that means connect things, transforms, converters. We have a lot of Kafka Connect stuff around, so syncing stuff into JDBC, databases, etc., Redis, Kafka. Redis and Cassandra. We have a lot of stream processors. We have a few custom solutions based on Spring Boot for certain edge cases where we need additional logic in. My team writes at the moment REST and gRPC services based on Spring Boot and Kotlin only. Also Kotlin DSL for Gradle. Our Android app recently relaunched completely in Kotlin. And some of our B2B teams, none of them is here right now. No. So they're also running around here, and they rewrote their PHP applications, their business customer-facing PHP applications in Kotlin. So that was my rush through, and I did it almost in time. If you are curious about how we use Kafka, there's another talk from last year from a friend of mine and me that you can dive into, recordings on YouTube. That's more about how is the architecture made up and less about Kotlin. But if you want to dive more into the aspects of how we use Kafka and what we do with it, then this is maybe the appropriate talk to look into. Dan, thank you very much.